Imagine a winter that didn't just linger for a few months, but stretched on for years. A relentless, bone-chilling cold that gripped the entire planet, cloaking the skies in ash and plunging life into chaos. Picture civilizations crumbling, ecosystems collapsing, and humanity teetering on the edge of survival. This isn't the plot of a dystopian novel. It's the real, harrowing story of supervolcanoes, geological titans that unleashed apocalyptic winters on Earth, reshaping climate, life, and the course of history. Let's dive into the raw power of these cataclysmic events, starting with one of the most infamous, the Toba Supereruption. We'll unravel how these eruptions triggered global cooling, decimated ecosystems, and left echoes of their devastation that still whisper to us today. About 74,000 years ago, the Earth roared in fury. In what is now Indonesia, the Toba supervolcano erupted with a force so staggering it dwarfed anything modern humanity has ever witnessed. This wasn't just a volcanic eruption. It was a planetary game-changer, a geological monster that spewed roughly 2,800 cubic kilometers of ash and rock into the atmosphere, enough to bury an area the size of Texas under a layer of debris several meters thick. To put that in perspective, the 1980 eruption of Mount St. Helens, one of the most famous modern eruptions, released less than 1 cubic kilometer of material. Toba was a beast on an entirely different scale. The eruption's immediate aftermath was apocalyptic. Toba's blast sent a colossal plume of ash and gas soaring into the stratosphere, where it lingered like a suffocating veil. Sulfur aerosols mixed with the ash, forming a dense haze that blocked sunlight and triggered a phenomenon known as a volcanic winter. Picture this. The skies darken, not for days or weeks, but for years. Toba's ash cloud spread across the planet, carried by high-altitude winds, blanketing continents from Asia to Africa. Sunlight struggled to pierce this murky shroud, and the Earth's surface cooled rapidly. In tropical regions, where stable warmth had nurtured lush ecosystems, temperatures dropped to levels unseen for millennia. In higher latitudes, glaciers advanced, and snowfalls became relentless. The world became a colder, darker place almost overnight. The atmospheric impact was staggering. Toba's sulfur aerosols reflected sunlight back into space, amplifying the cooling effect. Scientists estimate that photosynthesis slowed dramatically as plants starved for light, their leaves coated in ash. In regions like South Asia, where the ashfall was thickest, layers up to 15 centimeters, 6 inches, deep smothered vegetation, turning fertile landscapes into barren wastelands. Ocean surfaces cooled, disrupting marine ecosystems that relied on stable temperatures. The ripple effects were global. From the savannas of Africa to the forests of Europe, no corner of the planet escaped the chill. This wasn't just a temperature drop. It was a full-scale assault on the Earth's climate system. Monsoons weakened, rainfall patterns shifted, and droughts gripped regions that once teemed with life. In places like India, where Toba's ash blanketed the land, archaeological evidence shows a stark decline in plant and animal remains from this period, suggesting ecosystems were hit hard. The world's interconnected climate systems, thrown into disarray, set the stage for a cascade of ecological disasters. The volcanic winter didn't just cool the planet. It tore apart the delicate web of life. Ecosystems, finely tuned to their environments, collapsed under the strain. In tropical forests, where biodiversity thrived, the sudden loss of sunlight and warmth decimated plant life. Herbivores, unable to find enough food, starved in droves, and the predators that depended on them followed. Fossil records from this period show sharp declines in species diversity, particularly in regions closest to Toba. In Africa, for example, pollen records indicate a shift from lush forests to sparse grasslands, a sign of prolonged drought and cooling. Marine life wasn't spared either. The cooling oceans disrupted food chains with phytoplankton, tiny organisms at the base of the marine ecosystem, struggling to survive in the dim light. Coral reefs, sensitive to temperature changes, likely bleached and died off in vast swaths. Fish populations dwindled, impacting coastal communities that relied on them for survival. The scale of this ecological upheaval is hard to overstate. Some researchers estimate that up to 60% of terrestrial species faced extinction-level stress during Toba's aftermath. For early humans, the Toba eruption was a brutal test of resilience. At the time, our ancestors, Homo sapiens, and possibly other hominid species, were scattered across Africa, Asia, and Europe in small, vulnerable populations. The sudden onset of a volcanic winter would have been catastrophic. In regions like East Africa, where human populations were already small, archaeological evidence suggests a sharp drop in population size, a so-called genetic bottleneck. Some scientists argue that Toba's impact reduced the human population to as few as 10,000 individuals, pushing us perilously close to extinction. Imagine being one of those early humans. The skies darken, crops fail, animals vanish, and the cold bites deeper with each passing year. Tools and artifacts from this period, found in sites like India's Jwalapuram, show signs of human adaptation. Sharper stone tools, perhaps for hunting smaller game as larger animals disappeared. But survival was grueling. Communities likely fractured as resources dwindled, and migrations stalled as once hospitable regions became uninhabitable. Yet somehow, humanity endured, adapting to the new reality with ingenuity and grit. The Toba eruption wasn't an isolated event. It was part of a pattern of supervolcanic activity that has punctuated Earth's history. Other eruptions, like the Yellowstone supervolcano's blasts, 2.1 million, 1.3 million, and 640,000 years ago, or the Campi Flegrei eruption in Italy 40,000 years ago, also triggered volcanic winters with far-reaching consequences. Each event left its mark, reshaping landscapes, redirecting evolutionary paths, and influencing the rise and fall of early human societies. These supervolcanoes didn't just alter the environment, they forced life to adapt in profound ways. The genetic bottleneck from Toba, for instance, may have accelerated human evolution, favoring traits like adaptability and cooperation that allowed small groups to survive. Some researchers even suggest that the cultural explosion seen in human societies around 50,000 years ago, marked by advanced tools, art, and symbolic behavior, may owe a debt to the pressures of surviving such cataclysmic events. Civilizations, too, were shaped by these eruptions. The sudden climate shifts forced human groups to migrate, innovate, or perish. In some cases, volcanic winters may have spurred the development of agriculture as humans sought new ways to secure food in unpredictable climates. In others, they may have triggered the collapse of early societies, as seen in the decline of certain Neolithic cultures following smaller-scale volcanic events. The echoes of these eruptions linger in our collective story, reminding us of the fragility and resilience of life. Today, the scars of these ancient supervolcanoes are etched into the earth. Toba's caldera, now a serene lake in Sumatra, belies the chaos it once unleashed. Yellowstone's sprawling caldera, a tourist attraction in the United States, sits atop a magma chamber that could one day awaken. These geological giants are a humbling reminder of Earth's power and our vulnerability. Modern science allows us to piece together the story of these events through ice cores, ash layers, and fossil records. Greenland's ice cores, for example, contain sulfur spikes from Toba's eruption, confirming its global reach. Geologists study these clues to understand not just the past, but the future. While a supervolcanic eruption on Toba's scale is unlikely in our lifetime, smaller eruptions, like the 1815 Tambora eruption, which caused the year without a summer, show that even modest volcanic activity can disrupt global climate and food supplies. The lessons are clear. Our planet is dynamic, and its forces can reshape life in an instant. Supervolcanoes like Toba didn't just plunge the world into winter, they tested the limits of life, forcing plants, animals, and humans to adapt or die. Their legacy lives on in our genes, our cultures, and the very landscapes we inhabit. As we face modern climate challenges, these ancient cataclysms remind us to respect the Earth's power and to prepare for the unexpected. So the next time you feel a winter chill, spare a thought for Toba and its kin. They didn't just shape the past. They carved the path that led to us, survivors of an icy, ash-choked world still standing in the shadow of the Earth's fiery heart.